Have you ever wondered how we stay connected to the internet, watch live television, or make calls even in the most remote corners of the world? The answer lies high above us, with satellites orbiting our planet, acting as invisible bridges for information. But these satellites don't communicate with tiny cell phones. They rely on massive antennas on the ground. These giant dishes, often larger than houses, are critical for sending and receiving signals across vast distances of space. Without them, our world of instant communication would simply fall silent. Imagine you're trying to talk to a friend across a crowded room. It's much easier to hear them if they shout. Satellite communication works in a similar way. Satellites in geostationary orbit, positioned about 22,000 miles above Earth, act like relay stations. Earth stations, equipped with giant antennas, send signals up to these satellites. The satellites then amplify and redirect these signals to other Earth stations, sometimes thousands of miles away. This allows for communication across continents and oceans, bringing us closer than ever before. However, sending signals such a long distance presents a challenge. Just like your friend's voice gets quieter the further away they are, signals from space weaken as they travel through the atmosphere. That's where the giant antennas come in. Imagine shining a flashlight on a wall. Close up, the light is bright and concentrated. Step back, and the light spreads out, becoming dimmer. This is similar to how signals from space behave. As they travel, they spread out, losing energy. This phenomenon is described by the inverse square law. The strength of a signal decreases with the square of the distance it travels. This means that a signal twice as far away is only 1/4 as strong. This presents a significant hurdle for satellite communication, where signals travel thousands of miles. Thankfully, clever engineering in the form of giant antennas helps us overcome this challenge. Catching cosmic whispers. The power of parabolic antennas. Giant satellite antennas aren't just big for the sake of being big. Their large, curved shape, known as a parabolic reflector, is specifically designed to capture and focus weak signals from space. Think of it like a satellite dish collecting rainwater. The curved surface of the dish funnels the falling rain, concentrating it at a single point. Parabolic antennas do the same thing with radio waves. The curved surface reflects and focuses these faint signals onto a small receiver, amplifying them in the process. The larger the antenna, the more signals it can gather, just like a larger bucket collects more rain. This is where the inverse square law comes into play. The intensity of a signal, like light or radio waves, decreases with the square of the distance from the source. Mathematically, it's expressed as I equals sine P, or for PR2, where I is the intensity, P is the power of the source, and R is the distance from the source. This means that as the distance from the source increases, the signal strength diminishes rapidly, making large antennas crucial for capturing these faint signals from space. Bigger is better antenna size, gain, and frequency. The size of a satellite antenna directly relates to its gain. Gain, in simple terms, is the antenna's ability to amplify signals. A larger antenna surface area translates to higher gain and a stronger signal. This is crucial for picking up faint signals from distant satellites. The frequency of the signal also plays a role. Lower frequency signals require larger antennas, while higher frequency signals can be received by smaller antennas. This is why satellite TV dishes, which operate at higher frequencies, are smaller than deep space communication antennas used to talk to distant spacecraft. Conclusion: connecting the world, one giant antenna at a time. Giant antennas are more than just impressive feats of engineering. They are the unsung heroes of our interconnected world, silently facilitating global communication and scientific discovery. As technology advances and we push the boundaries of space exploration, these giant dishes will continue to play a vital role, connecting us to the cosmos and each other.